So last time we looked at very simple number sequences. So this time we're going to take what we were doing and just look at things that are a wee bit more complicated. So we're going to call n as like our term number. So it's going to be like 1, 2, 3, 4, and 5. And the terms in this sequence are 5, 8, 11, 14, and 17. So let's see, what is the difference? So when we've got a sequence like this, they don't look like the terms of any times table. Some are odd, some are even. So what we would do is, what's the difference between 8 and 5? So 5 add 8 is 3. 8 add 11 is plus 3. 11 add 14 is plus 3. So here we see each term increases by 3. But 1 times 3 is not 5. So say we wanted to find what is the 70th term in the sequence. We need a general formula. And we can't do 70 times 3 because that's not going to give us the right answer. But let's think, when you see a sequence increasing by the same amount each time, let's think about the numbers in the 3 times table. So underneath here, I'm going to write the numbers in the 3 times table. So 1 times 3 is 3. 2 times 3 is 6. Then we've got 9. Then we've got 15. And then we've got 18. Now let's look. So these are the multiples of 3. Let's think about what would we do to 3 to get 5. Well, we would add 2. 6 to 8, add 2. 9 to 11, add 2. And, oh sorry, I've written the wrong number here. That's 12, and that's 15. I missed. So yeah, 12 to 14, add 2. So see, we're doing the same thing to each one. So our general formula would be, take the n, we times it by 3, then we add 2. Now we can use this formula to find any term in the sequence. So that's a wee tip. When you get a number formula and you're not quite sure what the terms are going to be, think about what's the difference between the terms, and then write, if the difference is set, is the same for each one, write the numbers of that times table, and then see if you can link them together like we did just now. So now we're going to look at a few more examples of sequences. So let's look at this sequence. We've got 2, 5, 7, 12, 19. Now, let's think. If we go from 2 to 5, we add 3. If we go from 5 to 7, we add 2. If we go from 7 to 15, to 12, sorry, we add 5. From 12 to 19, we add 7. This is quite a strange formula. It doesn't seem to make any sense. But let's look. If you add these two numbers together, we get 5. If we add these two numbers together, we get 7. The difference on each term is the difference between the two previous terms added together. And this is in fact called the Fibonacci sequence. It's a Fibonacci type sequence. Sorry, it's not the actual Fibonacci sequence, type sequence. When the difference The difference between the two terms added together gives you what the differences of the next term. And just a useful little trick to remember. Let's look at this one. 0, 3, 8, 15 and 24. Now let's look at how these grow. That's adding 3, that's adding 5, that's adding 7, that's adding 9. Now at first glance that looks quite strange. What are we doing? But let's just think about these numbers. 3, 5, 7, 9. These are the odd numbers. The difference is increasing by this the subsequent odd number. And in fact, what we've got here is a sequence. The sequence is the difference of odd numbers, but also if underneath, let's write the square numbers. 4, 9, 16, 25. So for this sequence, each term in the sequence is the square minus 1. So it's the square minus 1. So if that was term 2, term 3, term 4, it would be n squared minus 1 would be this sequence. Now we're going to look at one which seems like there's absolutely no sequence at all. 2, 6, 4, 9. So this goes from 1 to 2. But this is minus 1. This one goes plus 4, oops, and this goes minus 2, and this goes plus 5. Now, the only kind of connection that we can see is opposite terms you're adding, and then you go add something, then take away something, add something, take away something, add something, take away something. So let's do something a bit different. Let's rewrite this sequence. 1, 3, 2, 6, 9, and we're going to skip and do alternate terms. So 1 to 2 is 1 times 2 is 2. Three, 2, 6. Oh yeah, and then oh, I've missed. That's why it's not working. Let's rub that out. And I miswrote the thing. It's 4, then 9. I couldn't understand why it wasn't working. 2 times 2 is 4. Now let's look here. If we go from 3 to 6, that's add 3. 6 to 9 is add 3. So we've got two sequences embedded into one sequence, which can be quite difficult to spot. So if you've tried all the other tricks have a wee look to see if you've got the two sequences embedded into one. It's just good to bear in mind that some of the examples that you've got in the textbook are really quite basic, and in the exam you may get something a bit harder. And just to have these different things on board, especially some of the first example, and to also being able to recognise what a Fibonacci type sequence is, how they propagate as well. These are really useful skills to be able to have. Hope that was helpful.